All right, last example. So as a challenge to yourself, pause this video and see if you can come up with the first one or two steps and then replay and work it with me. All right, so what do you think the first two steps should be? So this problem is sine of x over cosecant x minus cotangent x, and that's supposed to equal 1 plus cosine x. All right, what do we do first? There's no common denominator. We already have a common denominator. We're trying to get it to look like 1 plus cosine x, but we got cosecant and we got cotangent. So my first step would be, let's rewrite everything in terms of sine and cosine. That always helps, or it usually helps. So instead of cosecant, I will do 1 over sine of x, and instead of cotangent, I will do cosine x over sine of x. So I used reciprocal and quotient identities to rewrite in terms of sine and cosine. That was my first step. All right, in the denominator, I notice I'm subtracting. Let's go ahead and subtract this. We don't even need a common denominator. They're both the same. So this is the best kind of subtraction with a fraction. So sine of x on the top. On the bottom, we got 1 minus cosine x over sine of x. All right, so here we just subtracted. Okay. All right, so notice I got a numerator, but I have a fraction in the denominator. What does that mean? Well, that means I can multiply by the reciprocal of this fraction. Okay, so here I just multiply by the reciprocal. Okay, so what do we have here? We got sine squared x. Sounds like we know what our next step is going to be since we have this square over cosine of x equals 1 plus cosine of x. All right, so we just continued our multiplication. All right, what do we notice here? We got sine squared x right here. We got 1 minus cosine x down here. We're trying to just get cosines in our answer. This seems like we should be able to work with this. Okay, let's go ahead and write down the Pythagorean identity that goes with sine squared x. So I notice that, oh, if I move this over, I can solve for sine squared x, and that's what's in our problem. So I'm going to rewrite sine squared x as 1 minus cosine squared x. Whoops, this is no square. Let me white this out. And so this step was helpful for a couple reasons. First, it put us in terms of cosine, and our answer needs to just be in cosine, so that's good. All right, now it gives us a little something that's familiar on the top and the bottom. Let me write down my note that we use the Pythagorean identity. Can we cancel these? No, we cannot. These are different. This is cosine squared. This is cosine. We can't just cancel one of these because of this subtraction. All right, so next, there is a formula that is really helpful to notice. Are you guys familiar with the difference of squares formula? It's a way of factoring. And it basically says if you have two squares being subtracted, x squared minus y squared, we can factor it as x plus y and x minus y, so basically without their squares. And so I just noticed there is a difference of squares up here. 1 is 1 squared. Cosine squared is cosine times cosine, right? It's cosine squared. So we have 1, which is a square, minus cosine squared, which is a square. So we can rewrite this using our difference of squares formula. So we can rewrite this as 1 plus cosine of x times 1 minus cosine of x. And you can already see how this is helpful. All right, so on this step, I just use difference of squares. We are so close. All right, so what do we notice? 1 minus cosine x on the top, 1 minus cosine x on the bottom. We're just left with 1 plus cosine of x. Well, that is exactly what we were hoping to get. So we just verified this identity. All right, so that is the end. So are you able to simplify trig expressions? Are you able to verify trig identities? So this can be very tricky, but just do it one step at a time. Don't try to get to the end goal immediately because it can take a while. Remember the keys. Whenever you see a square, maybe try Pythagorean. Whenever you see multiple fractions, try to get a common denominator. Whenever things are really strange, try to rewrite them in terms of sine and cosine. All right, so we'll practice this some in class. Ask me questions if you have them, and that is the end of this section.